Hello students, this is Indrani Sen and in today's session we are learning ER model. We are continuing with the previous session in which we have already learned about the components of the ER model and the attributes, different types of attributes. In this session particularly we are going to learn only about relationships. We have already learned that entity relationship diagram is a diagram which is used by the software engineers to help prepare the database, and it is used to model the data in an organization. It consists of three important components: entities, attributes, and the relationships. We have already learned about the types of attributes in the previous session, and in this session we are going to learn about the relationships. The relationships in the entity relationship diagram are like normal relationship which exist in the world. Like we can talk about a student-teacher relationship, a owner and pet relationship, project and employee relationships, and so on. Here, to design the database, we need to have some kind of connections existing between them. We generally follow the relational model in which we have the tables and we have the connections between them in the form of primary key and foreign key. Because to establish those kind of relationships, we need to design the entity and the connections between them. These connections are called relationships derived from the real world term. We have relationships which can be classified into various different types according to the degree and the connectivity. A relationship in ER model is represented with the help of a diamond symbol and with the name of the relationship embedded on it. Two entities can be connected with this diamond symbol here as shown on the screen. There are some important points to remember about the relationships. Our relationship is an association between the entity set. Entity sets that are involved in the relationships are known as participants. The name which you give in a relationship is generally a verb because it depicts an action. The name which when you give on a entity, give to an entity, is generally a noun because it refers to a name of a person, name of a thing, name of a place, and so on and so. But while you are modeling the relationships, generally we prefer giving a verb to it. Relationships are always two ways, that is, they operate in both the directions. That is, we can talk about a program and course relationships, program to course, as well as course to program. Student and teacher relationship, a student to a teacher. For example, a student can be taught by more than one teacher. A teacher can also teach more than one student. So similarly, we can model the relationship in both the directions. It is a two-way interaction, not a one way. In ER model, as we have already learned, there are two types of models. One is a Chen's model and one is a crow's-foot model. According to the Chen's model, we have a relationship which is connected to an entity by a double line, which means it's a mandatory relationship. Mandatory means the entity which is connected by a double line is a mandatory entity. We'll learn more about mandatory and optional entities in the next slides. Similarly, we have an optional relationships. We can have mandatory many relationship, optional many relationship. Mandatory and optional refer to the participation, while one and many refers to the cardinality. What is participation in a relationship? The participation of an entity in a relationship indicates its extent of involvement of the entity in the said association. In a relationship, there has to be at least one or more than one entities which are connected in the relation. Now we need to know that their association is mandatory or optional. Optional participation occurs if one entity set does not require being present in a particular relationship. We will see the examples of mandatory and optional relationship. Mandatory participation exists if one entity occurrence requires a corresponding entity to occur compulsory in a particular relationship. So here we talk about a person and a passport. Now consider the two entities associated in the relationship, person and passport. Now here, the for having a passport, for having a passport, a person entity is compulsory. That is, without a person, a passport cannot happen. But for having a person, a passport is not necessary. A person can exist without a passport also, but a passport cannot exist without a person. So here, person is a mandatory participation, while passport is optional participation. We have given also 1 and 1 here to indicate that there is a cardinality of 1 to 1. As for one person, there has to be only one passport. Even for one passport is connected to only one person. Next, we talk about the strength of a relationship. There are two types of relationship. One is an identifying relationship, one is a non-identifying relationship. Depending on that, we have two types of entities here in the ER model. One is a strong entity, one is a weak entity. A strong entity is indicated by a single rectangle, while a weak entity is represented by a double-lined rectangle. A strong entity can also be identified by a primary key. That is, a strong entity has to have a unique primary key, while a weak entity generally does not have a primary key. The primary key in a weak, if you have a unique identifier in the weak entity, we call it as a determinant. Like for example, we are talking about a passport. A passport has a passport number, which is a passport number is a primary key. It's a unique identifier. So it can be a strong entity. Similarly, we can talk about a student. A student has a unique primary key, which is a roll number. And so a student is also a strong entity. But depends on if you are connecting a student to a program, and you are considering every class, every program, like in program has different divisions, and in every class the roll number is repeated. In that case, the roll number no more remains a primary key. In that case, you need the help of the division as well as the class. So here, student will no more be a strong entity. It will be a weak entity, which is identified by the roll number as well as the class ID, program ID, as well as the division. So it depends on the type of scenario in which you are implementing the ERD. To summarize, an identifying relationship is a relationship between two entities in which an instance of a child entity is identifying through its association with a parent entity, which means a child entity is dependent on the parent entity for its existence. Like for example, we talk about a department and a company. A department cannot exist without a company. A non-identifying relationship is a relationship between the two entities in which an instance of the child entity is not identified through its relation with the parent entity, which means the child entity is not dependent on the parent for its existence and has its own identity. Depending on the identifying and non-identifying relationships, we have two types of entities in ERD model. One is known as a strong entity, another is a weak entity. A strong entity is an entity which is identified by unique primary key, which is identified by unique key. For example, you can talk about an employee who is identified by an employee ID, a student who is identified by his seat number. Then we can talk about a project which is identified by the project number, and so on. A strong entity is represented by a single-lined rectangle, while a weak entity is represented by a double-lined rectangle. What is a weak entity? A weak entity is an entity which does not have a unique identifier. For example, we can talk about a mark sheet. A mark sheet does not have any unique identifier. A mark sheet is represented with the help of, or identified with the help of, the seat number of the student whose mark sheet it is. So it can be considered as a weak entity. A weak entity, though it does not have a unifying identifier, but still it may have something to identify it, which is also known as discriminator, which may not be unique. And we underline the discriminator of a weak entity set with a dashed line, in contrast to the strong entity in which the primary key is identified with a underline. Here we are taking the example of a student and mark sheet. A student here is a weak entity who has the unique identifier student roll number, name, in which roll number is the primary key, so it is underlined. Apart from the roll number, it has name, program and year of study to identify the student. And student has a mark sheet. A mark sheet can be identified by the exam name, date, grade, percentage, total. Grade, percentage or total are represented by dashed border because they are derived attributes. Derived attributes means they need not be stored, they can be calculated. They need not be stored in the database. Next we have marks, which can be a composite attribute, which can be divided into course 1 marks, course 2 marks, likewise course 3, 4 and 5 marks. And here a discriminator, you can give the exam name as the discriminator, which will discriminate a mark sheet of a particular exam from the others. But to summarize, to identify a unique mark sheet, you need the seat number of the student as well as, or roll number of the student as well as the exam name. Then only you will be able to identify the mark sheet of the student. You can see here, mark sheet being a weak entity is represented with a double lined rectangle, while it's a identifying, it is connected to the strong entity with an identifying relationship, which is a has relationship, which is also identified by a double lined diamond. Next we talk about the cardinality of a relationship. There are 4 types of cardinality in a relationship, which is one to one, one to many to one and many to many. What is cardinality? It is the number of possible occurrences of an entity set that may relate to a single or multiple entity sets with relationship. We can take the examples of one to one. In this type of relationship, if there are 2 entity sets, entity can be connected only to one entity corresponding occurrence of an entity. We take the example of an employee and PAN card. That is, one employee can have one PAN card. Similarly, one PAN card is associated with only one employee. Person and passport. It is also a one-to-one entity, one-to-one cardinality. One person can has a single passport, and one passport is connected to a related to a single person. Similarly, we can talk about one to many and many to one. Since there are two entities involved in a relationship, we can have one to many, and on the reverse, we can talk about many to one relationship. In this type of relationship, one entity may be associated with one or many occurrences of other participant entity. Here we can talk about branch and account entity, in which one branch can be associated with multiple accounts. That is, in one branch you can open multiple accounts, but one account is associated with only one branch. So it is one to many relationship. Similarly, we can talk about account and transaction. Account and transaction, in which one account has multiple transactions, but one type of transaction is related to only one account. Similarly, we talk about many to many. After learning one to one, one to many, we are learning many to many. In this type of relationship, one or many occurrences of an entity set can be related or associated with one or many occurrences of the participant entity set. Here we can talk about doctor and patient relationship. One doctor can have multiple patients. Similarly, one patient can go to multiple doctors. So patient to doctor relationship is many to many, which is represented by M to N. After learning the cardinality, we can talk about we can take examples of more relationships of the cardinality. Try to find out examples of one to many relationships and more many to many relationships, and note in your notebook. Next, we talk about the degree of a relationship. The degree of a relationship corresponds to the number of entity sets participating in the relationship and is classified into, we have four types of degrees of a relationship. Number one is unary, number two is binary. Unary, as the name suggests, unary is being derived from the Latin word uni. Uni means one, and a relationship which consists of only one participating entity. Similarly, binary is contains the word bi. Bi means two. Similarly, ternary, it involves three participating entities. And finally, we have nary. If you have more than one relationship, more than three relationships connected, more than three entities connected to a single relationship, we can talk about nary relationship. In unary relationship, has only one participating entity. In this type of relationship, a single entity set is connected to itself, and it is also known as recursive relationship. We can take the example of an employee and manager. Like we can talk about employee manage employee. A manager is also a type of employee. So here employee manages multiple employees, one to n relationship, and the degree of the relationship is unary. Similarly, we talk about binary relationship. When two entities are participating in a relationship, the relationship is called binary relationship. Here we can talk about account and transaction. In this case, a transaction is taken as a weak entity, and the transaction has a unique key, but that is a discriminator. That is a determinant. Okay, that is a determinant, not a primary key. And one particular account has many transactions, while one particular transaction is associated with only one account. So we have one to many, and this kind of relationship is a binary relationship. Why we have considered transaction as a weak entity? Because a transaction will not have a meaning directly. If you see the transaction, you will not be able to derive any meaning from it unless and until you are associating an account number with it. That's why transaction is considered to be a weak entity set, and it is connected to the account, which is a strong entity set, with the help of a identifying relationship, and that is modeled using double diamond. Next, we talk about ternary relationship. When at least three entity sets are involved or participate in a relationship, the relationship is called ternary relationship. Here we can talk about entity sets like student, teacher, and lecture. Well, all of them three are involved in a relationship. The cardinalities of ternary relationship can take many forms. We cannot now here, the cardinality is not only one to one, one to many, many to one, and many to many. It is not limited to only four cardinalities. We can have many cardinalities which can take the form of 1 is to 1 is to 1, 1 is to 1 is to n, 1 is to m is to n, and m is to n is to n. We can formulate the business rules before writing, modeling a ternary relationship. For example, for this student, lecture, and teacher, we can model that one student participate in many lectures which can be taught by many teachers. Similarly, one lecture is taught by one teacher, is attended by many students, and one student attending one lecture must have one teacher. Depending on this, on the rules, we can formulate the cardinality and we can draw the model. Here we can see we have drawn a model of student, teacher, and lecture, in which here student has student role. Program is identified by the program in which he is enrolled, his name and his address. Who participates uh, in the lecture which is taught by the teacher. A teacher is identified by the teacher ID. A lecture is identified by the room where the lecture is held, the date and time where the lecture is held. It's a composite key. You can see it's a composite key. It does not have a primary key. It contains more than one key which is identifying the lecture. A lecture cannot be identified by only room number. It cannot be identified by only date or only time. It can be identified by three different attributes taken together. And we can have a relationship cardinality m is to n is to n. Apart from this classification, we have more two types of classification, which is one is known as generalization, another is known as specialization. Depending, it models the ER model in a hierarchical level. What is specialization? It is a process by which an entity set is decomposed into subgroups consisting of lower level entities which inherit the attributes of higher level entity sets. The opposite to specialization is basically generalization. If we take a bottom up architecture, that is, we can go from lower level entity set to a higher level entity set, it depicts generalization. To illustrate the concept, we can take consider an account which can be of various types. An account can be of savings, credit card, fixed deposit, and loan, various types. Specialization is represented by a by a triangle, which is you can name it as either relationship. The process is depicted by a triangle component labeled either. In this diagram, we can see an account parent entity which is connected to multiple child entities. An account has several types of accounts we are talking about. We can talk about savings account, credit card account, fixed deposit, and loan. All of them are some kind of accounts. Here, name and date of birth is a multi-valued attribute here, because we can have, for a single account, we can have more than one account holders account holders who are sharing the same account number. We have depicted here is a relationship which is connected to the savings account. Now savings account will inherit the attributes account number, name, address. Apart from that, it will have debit card number, minimum balance, which are the specialized attributes. Similarly, a credit card, apart from having the account number, name, address, everything, it will also have a CVV number, credit limit, expiry date, etc. So in this way, we can model a hierarchical kind of a model with the help of ER diagram. ISA is also known as type of. That is, we have different types of the same parent entity. If we write the ISA in opposite direction, it is representing generalization. Generalization is just the reverse form of the specialization. That is, if we are talking about various different specialized entities which are converging together to form a single parent entity, it is called generalization. Next, we can talk about aggregation. Aggregation is an abstraction technique with which the relationship can behave as an independent entity. Here, a relationship, instead of behaving like a relationship, it can behave as an entity here. And we need to design a relationship between a collection of entities and relationship. In that case, we can represent the collection as an aggregate. Here we can talk about the relationship like student, teacher, and lecture. Here all of them are becoming a single entity, and we are connecting to the records. Okay, records is a relationship which is connecting this multiple entity collection with another entity which is called attendance. That is, for attendance, for calculating the attendance, I need the student records also, I need the teacher's records also, as well as I need the lecture. So here the student, teacher, lecture, and the participant relationship is not a single relationship. It is called an aggregation relationship. I hope you have understood all the different types of ER models. We'll study a case study. We'll do a case study here, and I'll show you step by step how to draw an ER model for a particular case. Thank you so much for listening.